What's up, everybody? Good morning. It is Thursday, and we are about to begin SAT Khan Academy practice problems. So we will be getting this or continuing this trend every morning. I'm really going to try and make these broadcasts happen right at 6 a.m. PST. It's sort of been bouncing around in that rough vicinity. We've had them come out at 5:50. We've had them come out now at 6:15. So as I nail this routine down, we're going to get more consistent and more accurate with the times. But hopefully, either you on the West Coast early risers, on the East Coast, not as early risers, and people all over the world can check it out if they want clarity on these SAT problems to learn every morning or whatever time it is in your neck of the woods. All right, without further ado, today we're going to be going over, let's see, interpreting linear functions. And we're going to be going sort of top down. That's in the Heart of Algebra section from Khan Academy. So I'm going to start today like this. Let's do a little screen share. I'm going to start today on the Khan Academy sort of general practice page. You can see what it looks like when I go to these practice problems. So let's do a screen share here. So what we're doing now is we're on, so again, you go to khanacademy.org/SAT, and I clicked on practice. And then I clicked on the math. You see how they have reading, writing, essay, and then math. That's the math tab. Here's where you see all these different problems. And let me get this up here like this. Oh, I'm going to have to disconnect this like this. Okay, so now let's do a little split screen action. I like this guy over here. Split screen, and we are ready to roll. That's from yesterday's morning broadcast. Now we click interpreting linear functions, practice, and boom. Okay. Yeah, they didn't really have a lot of these problems on the SAT back when I was in high school. They're increasing their presence much more now. Question 1, 0.3P plus 0.25G equals 57. A homeowner uses G hours of natural gas heat and P hours of heat from a pellet stove per hour to heat her house 1 month with a total of 57 therms of output. How many therms per hour does the pellet stove output? So the question is, here we go. We've got, this is, the G represents hours. The P represents hours. They're not asking you to make any calculations. All they are asking you to do is say, how many therms per hour does the pellet stove output? Now look at the pellet stove. It's represented by P, and it's got this coefficient in front of it. Often, whenever you have something representing hours like P, whatever that coefficient is, that's going to be, let's say, the hourly charge, or that's going to be the hourly revenue, or in this case, the hourly therm output. Because literally, think about it, as P goes up from 1 to 2 to 3, every hour, this thing is going to be increasing by 0.3. Okay, so that is literally per hour the hourly output. So we go 0.3 like this, we check answer, and boom, the green means it's correct. Okay, now let's go to this one. After Hero's family photo shoot, the photographer sells the printed photos by the sheet. Let's clear the board here. And Hero has a $200 credit from a prior session, and the above equation gives the total credit left, C, in dollars, if he buys, what is it, S sheets. Oh, there it is. Yeah, that's a little variable. So Hero has $200 credit from a prior session, and the above equation gives the total credit left in C in dollars if he buys S sheets. How many sheets can Hero purchase with its credit? And it is, okay, so this is crazy because it doesn't give the price. Now, you can interpret the price. The answer is going to be 5 sheets, but let me explain why. So this is kind of a strange equation. I think they've intentionally made it a little crazy, or they factored it. If you distribute this 40, let's go like this and like this. That's an S. Again, they use that S. It's so confusing. You saw yesterday, I almost made a mistake because I confused the 5 and an S. It's a really dangerous thing. So we have 40 times 5 is 200 minus 40S. Now, if you distribute the S, this equation makes a lot more sense because now we've got the $200 credit, right here. He has this $200 credit from a prior session, and this gives the total credit left, C, after he buys S sheets. So now we can see, well, how much does a sheet cost? Now we see that coefficient. Remember, the coefficient is the per whatever. One sheet, we're going to be spending 40, right? 1 times 40. 2 sheets, 2 times 40, which is 80. So you can now see that with this credit, it looks like he's going to be able to buy 5. You could also tell from this equation the same thing, that this is going to hit 0 at once he buys 5 sheets, but just so it makes a little more sense. Okay. Let's go on to the next one here. We've got T equals 1/4 P plus 2. And it uses the equation above to determine the number of hours T. All right, T is the number of hours. And I'll even do this. To roast a P-pound turkey. Pounds. How many more minutes would it take Anna to roast a 13-pound turkey than a 12-pound turkey? Okay, now we actually do have to plug in values. Well, actually, you don't. You can actually figure it out without. But let's say hypothetically you are stuck or not sure what to do. You could plug in values. So let's try it out. First, let's do, and I'll tell you why you don't have to after I solve it this way. So 14 times 12. So we're going to first calculate the time it takes to roast a 12-pound turkey, right? Because we're just literally plugging in 12 for pounds. And then this is for a 13-pound turkey. So what's 1/4 of 12? That's actually 3 plus 2 equals 5. So guess what? Now it says, so this is in hours, right? So it takes 5 hours to roast this guy, the 12-pound turkey. What about 13? Now, what is 1/4 of 13? It's 13/4. I'm going to write it up here, 13/4. But how would we represent that? Well, that actually becomes 3 1/4. We could say 3 1/4. We could also say 3.25, whatever you prefer. Right? This reduces to 3 1/4 because 4 goes into 13 3 times, and we have 1 left plus 2. We add these together, add the whole number of pieces, and that's 5 1/4 hours. How much longer does it take? It takes literally a quarter of an hour longer. Look at the difference between these two. A quarter of an hour longer. And then they throw another curveball. They don't give you the answer in hours. They give it to you in minutes. What is a quarter of an hour? Well, you take, if you turn it into minutes, it's 60 minutes divided by 4, which is 15 minutes. All right, think about it. You have 15 minutes, 30, 45, and an hour. So that is your answer there. 2 more. Fine, next. Okay, so we have L equals 1.1 J. Jacob and Liam purchased the same camera from 2 different stores that charge different amounts. The equation above gives the price that Liam, L, paid to, what is it? Liam paid compared to the amount Jacob paid. It looks like Liam's always paying more. What does 1.1 mean in the equation? If you're not sure, you plug in some numbers. Now, what this literally means is when you multiply something by 1.1, 1.1 is the decimal equivalent. Now, I know this, but you may not know this, and that's okay. I know that this is the decimal equivalent of 110%. If you're really good with your percentages and decimals, you may pick up on that too. So right off the bat, since this is 110, we multiply it by J's. It means that Liam every time is paying 10% more than whatever Jacob paid. And it just is what it is. Right, you multiply because the 100 part, it's not 110% more, it's 10% more because the 100 will give him the actual value, and then the extra 10 or 0.1 will give him an additional 10%. But why? How do we know that? Well, if you're not totally sure, again, you can test out some values. Let's pretend that Jacob paid $100. Okay, and this is a no calculator section problem. You may have to actually multiply it out. But what's 1.1 times 100? It's 110. So guess what? When J pays, make a little table. When J pays 100, L pays 110. Let's try another one. Let's just try a random value. I always try and pick easy values like this, like 100. Maybe let's try, oh no, 1,000. No, 10. Let's pretend he pays $10. What's 1.1 times 10? 10 times anything, you move the decimal once. So then in that case, Liam pays 11. So J pays 10, Liam pays 11. What's happening each time? The percentage change, right? It's not $1.10 more every time. We can quickly cross off C and D. Is going up by, in this case, going up by 10. 10 is 10% of 100. It's going up by 1 here in the second one. 1 is 10% of 10. So Liam is just paying 10% more. You see how a nice chart like this can really help you figure things out. Finally, let's do number 5. V equals whatever. Okay, let's jump to the sample variance V in the expected total premiums of L, low risk beneficiaries, and H, high risk beneficiaries, based on an underwriter's premium allocation, is given by the equation above. The values of L and H are independent. What is the best interpretation of 451H as shown in the above equation? Okay, so this is, let me think about process this for a second. This is a crazy question in terms of what they're trying to throw all these different terms and more or less intimidate you and make it seem way more complicated than it is. I bet you this won't be as complex as I think once we start reading through these answer choices. Like I look at this and sample variance, okay, variance is sort of like, well, I think in this case, what they're talking about, usually variance is sort of like the distribution of values in whatever it could be. So if we have a lot of prices, for a video game, the variance might be high if they're scattered all over the place. So let's look here. So we have low risk beneficiaries and high risk beneficiaries. So what is the 451H? Of course, the 451H relates to the high risk beneficiaries. And we know that all these choices relate to the high risk beneficiaries. So what makes sense? 451H high risk beneficiaries? No, we know that this has nothing to do with the terms. And at the end of the day, it's like the high risk, the H is probably going to represent the quantity, like the amount of high risk beneficiaries. That 451 is some sort of constant that's going to just keep amplifying whatever our number is of high risk beneficiaries. A is gone. The total variance due to high risk beneficiaries, and it's not going to be, it actually could be B. Hold on, let me keep thinking. The variance in premiums for a high risk beneficiary is 451H. Total variance due to high risk. The variance in premiums for a high risk, the expected total premiums. So this isn't about premiums because, again, so it's not going to be D. It's total variance. Okay, the sample variance in the expected total V in the expected total premiums. So V is the sample variance of premiums. The total is the sample, the variance in premiums. Oh, I see what they've done. It's not, yes, the variance in premium. All right. So full disclosure, I'm not 100% sure. Like this is actually even, the language is confusing me a little bit. I'm feeling like it's going to be this one. So what they've done is they've taken, what is it? Total. See, they use this term, expected total premiums, the expected total premiums of L here. And they put total down in this one in B, and they put premiums down here. But again, this is just, it's not going to be, I mean, this one's kind of throwing me for a loop. I'm going to go with this because they don't mention premiums here. And this is expected total premiums of low risk beneficiaries. Hold on. Okay, let me think one more second. Variance in premiums for high risk. I'm going to go with C. Could be B. Let's see. It's B. So I actually got it wrong. Let's read the explanation together. The question body tells that H is the number of high risk beneficiaries. The coefficient of H performs a very similar function. Therefore, we can use the definition. Say it's 451 in the change V with respect to each risk beneficiary. So the variance due to one high risk beneficiary is 451. Yeah. So what? And then that one, the total variance is high. So this answer describes 451, which is the variance in premiums due to one high risk. Oh, wait. So the variance in premiums for a high risk beneficiary. Oh, yeah. I missed that part. So now that I think I didn't see this for a high risk beneficiary. I missed that part. Now, like I said, sometimes I'm doing these problems for the first time, and I definitely am not perfect, but it's going to be all about that total. So that total was important, and I missed that part right there. But that's why it's wrong, because this isn't for just one particular beneficiary. This is the total. So this will be all the high risk beneficiaries. Well, all right. Hopefully that was still helpful and that still made sense. So let's jump back to my live stream here. All right. I'm going to stop sharing. All right, cool. So that is it for the SAT problems today. Hope you guys enjoyed it. Hope it was helpful. If you have any questions or comments, you can always leave comments in the video. and reach out to me. I will do my best to respond immediately. I know that one of my subscribers yesterday told me that I need to be watching the comments as everything comes in. Nicholas told me that, and I'm still trying to figure out my setup so that I can optimize that, but we'll see how it goes going forward. All right. Thank you guys so much for joining, and you guys have a great day. Take it easy.